All right, well, welcome everyone to the Teamcenter Manufacturing webinar, where we're going to be focusing today on part manufacturing. My name is Kyle Heithaler, the Tata Technologies iProduct Sales Manager, and I have with me Pradeep Peter, our Business Development Manager. Before we start, I'll be going through a small overview of Tata Technologies, and then we'll jump right into the technical info. For those unaware, Tata Technologies is a global business with the vision of engineering a better world. It's our mission to help the world drive, fly, build, and farm by enabling our clients to realize better products with the ability and flexibility to deliver projects globally depending on specific client needs. Our proven global engagement model has pushed the boundaries of distributed engineering, opening access to global talent at a scale, and then passing resulting commercial benefits back to our customers. Tata Technologies focuses on 3 lines of business. ER&D is at the core of everything we do. Whether it's through project-based work done on-site, near-shore, or offshore, or by fulfilling a variety of staffing needs at client sites around the country, we help our customers increase their capacity to create. Our PLM group focuses on our ability to provide clients with a process to create, which helps manufacturers efficiently manage the massive amounts of data created by PLM applications. And finally, we help clients better leverage their digital assets, improve productivity, and connect manufacturing operations to the enterprise through our CEIT services. Our clients include many of the world's most renowned automotive, aerospace, and IHM OEMs and their extended supply chains. And with that, I'm going to pass it over to Pradeep to take us into part manufacturing. Pradeep?
Yeah, thanks, Kyle, for that introduction. Hello, everyone. I'm Pradeep Peter. Like Kyle mentioned, I'm part of the business development team here in Tata Technologies. In today's session, we will see some of the Teamcenter manufacturing capabilities, specifically around part manufacturing. So in the last session we had an introduction to Siemens PLM vision to address the engineering and manufacturing world disconnect by storing and managing both product and production data in the same platform, right? And that too on a global scale. We got touched upon the concepts like E-BOM or the engineering BOM, manufacturing BOM or the M-BOM, bill of process, routings, bill of plans, so on and so forth. In today's session, we will see some of those concepts in action, specifically around part manufacturing. Now, we'll have a separate session for assembly manufacturing, and in fact, that is going to be the next webinar. So starting with a quick topic overview. Now, when we talk about part manufacturing, typically this is the environment that is in place for many companies. The design engineering world is here shown on the left-hand side, and the manufacturing engineering world, where we are still in planning stages, is shown in the middle left side. The manufacturing execution, which goes closely with order management, is here shown on the right-hand side. As you can imagine, there is tons of interactions that goes between these different areas, right? A big challenge to all this is if the systems managing these areas are all disconnected. Now, that's most often the case with a typical company, right? They may not be fully disconnected, but still they often do have breaks in their data management and processes. Now, with this disconnect, a lot of time can be spent just finding answers to the most basic questions like, am I using the latest version of the part program, right? Or am I having the latest G code? Has the part file been changed since I generated my part program? Or is this the correct tool list I should be using? Now, even with the best applications and equipment to manage each specific area, managing the communication between users and department in this chain can be a big challenge if they are indeed disconnected, right? So IDC report estimates that information workers spend close to 13 hours a week with information gathering and analysis. Now, that's a lot of time wasted in searching for non-existent information, failing to find the existing information, validating the information after you find it because you don't really trust that's the right information, right? Or recreating the information that can't be found. That's like you are reinventing the wheel. Now, that's a big challenge for companies when we have disconnected system. Another challenge can be the amount of data that's involved with manufacturing. Anyone who has dealt with manufacturing data can appreciate how the manufacturing data grows exponentially with respect to the design data. They say manufacturing can easily involve up to 100x more data than design. Now, that's a lot of data, right? And a lot of complexity too. Now, what is the leading practice to address this challenge? The leading practice is to have a common information platform connecting all domain areas from product design to manufacturing engineer to shop floor, right? Now, when we have such a solution with a centralized information and process management platform that connects all domain areas and that acts as a single source of managed information, it can help companies like yours to decrease time to production and improve design for manufacturability. It can help to improve collaboration across different departments. It can help to maximize the use of data and assure more accurate and complete manufacturing planning and execution. It can help to link design world to manufacture product and production planning. It can also support automated document generation and publication right to the shop floor. Now, let's see the solution summary around Siemens PLM, how they implement this leading practice, right? When we talk about part manufacturing, often it is, specifically when we talk about Siemens part manufacturing, often it is misunderstood just for NXCAM, right? And sometimes the process gets oversimplified too, right? Like a designer, once a designer completes the design, they pass it on to the CAM guy. He just creates a G code or something, right? Then it's being sent to the DNC, right? Well, there is much more to part manufacturing, right? A typical part manufacturing involves 3 stages, which is starting with process design, wherein it involves part and process development or stage model development, fixture workholding development, tool design. Then we move on to process definition, where we do the process planning, resource management, NC programming, right, and the CMM programming. Once all those things is finalized, we move on to the process delivery stage, wherein the shop floor access is involved, DNC is involved, and release management and security is involved, right? Now, when we are talking about this detailed 3-stage or 3-step process, it involves the development, management, and verification of a comprehensive technical work package, right, for part manufacturing. And a holistic part manufacturing technical package involves a lot of elements. It's like a cookbook for how to manufacture this part, right? And it contains elemental breakdown of sequence of operations and supporting artifacts. Now, not all companies use everything I'm showing in the slide, or the complexities and the level of detail that's associated with each of these artifacts can vary depending on the type of part being manufactured, the domain you guys are in, and if you have any regulatory requirements, right? So now let's see Siemens PLM solution highlights to come up with this holistic technical package. Well, what I'm going to show here is the art of possible. You don't have to start with everything I'm going to show here, or you don't have to adopt every functionality I'm going to show here on day one. You can start with what is relevant for you and of immediate need for you, and then you can consider adopting the rest of the technology in a phased manner. So going on to the solution highlights, right, starting with part in process development. With NX, right, we have capabilities to automate in process or stage model of a part, right? While doing so, we can associate the stage models to the original design using wave and synchronized technology. We can incorporate all relevant PMI in each stage, right? And once the stage model or bill of parts is kind of created, we can store it back to Teamcenter, right? So we will see a quick video of this later. Moving on to fixtures and workholding. With NX and Teamcenter, we can associate the stage models for again fixture or workholding design, right? So that they are connected. We can also take advantage of the Teamcenter classification and resource cataloging capabilities to encourage reuse by standard library component creation. With the linkage between the design and the tool and the stage model, we can also track where used through the Teamcenter BOM reporting capabilities. Moving on to process definition solution highlights, starting with process planning. With Teamcenter Manufacturing Part Planner, we can define processes, operations, and activities to manufacture the part. We'll see a video of that, and we can also assign the work areas where it's actually going to happen, and we can enforce controls based on that, right? We can track resource items being used in each operation, right? Like fixtures, hand tools, so on and so forth. It supports revisions and status of the plans, right? So you can, you don't have to start from scratch all the time. You can actually revise an existing plan, right, and make changes, and you have the complete traceability to what changed. It supports alternate process routes. Another cool thing it can do is actually once you complete a process plan, you can make it as a template, right? So the next time you have a similar plan coming up, you are not starting from scratch. You are reusing all the good work you have put in earlier, right? It also support delivering of work instructions with 3D graphics and also with standard text, right? Moving on to resource management and Technomatics Resource Manager, which helps to rapidly build resource assemblies and sub-assemblies using guided component search. Again, it also has classification-driven resource catalog, right? That they, search and retrieval of the right resources is very easy, right? We can incorporate standard libraries. It has embedded visualization capabilities. It's integrated with NX CAMCM cutter, fixture, and machine retrieval. Of course, it has integration with Teamcenter Part Planner for resource retrieval and process structural reuse, right? When we come up with that process plan in Part Planner. Moving on to NX CAM and CMM. I'm sure most of you will know that Siemens has the best industry capabilities when it comes to CAM and CMM. Some of the highlights are shown here. I'm not going to discuss them in detail. I will right now move on to the process delivery, which involves shop floor access, right? With the Teamcenter electronic work instructions, it helps to deliver a detailed process plan structure and supporting documents and with visuals to the shop floor, right? Again, all the information is actually coming from that common information platform, which is Teamcenter, right? Nothing is actually offline. Everything is coming from Teamcenter. But a separate view is actually a simplified view is presented to the manufacturing users, right? That way they are more effective. We can integrate it with MES platforms, right? Like Semantic IT or CAMStar, and even with competitor IT like MES like Appraisal. It also integrates with issue management for quality feedback. When it comes to DNC, with the shop floor connect for Teamcenter, we can download, upload the G code between machine controls and Teamcenter, right? Now, that way, the G code is also stored and managed in Teamcenter, and we can enforce, security and access controls for this data too, right? It supports display of related documents and drawings and models along with the G code, right? And the uploaded programs can be saved to Teamcenter and can be marked up, right? Now, when we are storing and managing manufacturing data in Teamcenter, right? Teamcenter has some foundational capabilities which we all leverage for the engineering side of things, right? The same can be leveraged for manufacturing too, right? Things like access controls, release statuses, right? And workflows for controlling the process maturity. All those things can be leveraged for manufacturing data too, right? So if you are using it for engineering, why don't you use it for manufacturing too, right? Again, with the Teamcenter integration to ERP and MES platforms, right? We can actually support sending manufacturing data to downstream systems, right? It also supports revision and effectivity control, right? So all those foundational capabilities that exist in Teamcenter, which you might be leveraging today for engineering, can be completely leveraged for manufacturing too. Now, some of the other capabilities which we can leverage when manufacturing data goes into Teamcenter is change management capabilities, right? Program and project management, because some of the deliverables for a program or engineering programs will be manufactured components, right? Requirements management, there will be manufacturing and quality requirements, right, in your initial requirement set. So when you want to have traceability between manufactured items and the quality things, we can leverage Teamcenter requirements capabilities. Like I said earlier, it supports enterprise integration, be it ERP or MES, right? Then we can also leverage issue management CAPA capabilities that's available in Teamcenter for manufacturing side too. Okay. So that was a quick overview about the solution, right? Now let's see some of these solutions in action. So what I'm going to show here today is a part that's been completed the design, right? The designer has completed design. Now it's actually going to the manufacturing engineer. First for part and process development, we will start with that. Then it will go to a process plan development through part planner inside Teamcenter. Once a process plan is kind of once the process plan kind of get matured, it will go to the next step, which is the NC programming, right, and the G code generation. And the final step, of course, is actually getting this G code in a machine and actually running it to manufacture the part, right? So let's start with part and process development. So as a manufacturing engineer or a planner, there is a request arriving in my work list, right? Where does it come? It comes into my work list, right? To my Teamcenter work list. It's no emails or anything. I have work. It's part of the workflow. It comes right into my inbox, right? With the associated part for which I have to create a in-process part, right? So what I do, I don't have to go and search for the part or anything. I can open this part right from my work list, right? Since it's actually in Teamcenter. So I click on the NX button, I open the part in NX, right? So it's a crankcase here for which we are going to create an in-stage or in-process model, right? So I can have basic automations to create a part in process assembly framework, right? So in this case, I have an external DLL. I'm going to load it, which is going to ask me, hey, how many stages we are talking about, right? So I'm going to have 5 stages. We have that program which creates 5 copies of that crankcase, right? Now, as a next step, what I'm going to do is actually I'm going to link between each stage, right? I'm going to create the wavelengths for that, right? Now, some of those things can also be automated, but in this case, I'm actually going to do it manually. Now, as a next step, right, I'm going to create the explorer view, right? Even this can be automated if you want to, right? In this case, I'm doing it manually, right? So that we are actually visually showing each step separately. Okay, so I do my design magic, I do my explorer view, all right? You can see all the stages, right? Now, each stage is actually linked, so if you update one stage, the next stage will also get automatically updated, right? So sometimes we have to add some detail which is not in the design, like a thread, right? Sometimes that's not in the design. But for manufacturing, that's important, so we are going to add that, right? Now, once you add in stage 1, it gets pushed to the stage 2, stage 3, and so on, right? So in each stage, what I can do is I can actually highlight what is the operation that's going to happen, right? And or on which phase I'm going to do the machining operation, right? And I can give a different color code. This way, we can reuse this for work instructions, right? So when an operator see, hey, at this stage, this is the surface which is red, that is the surface which I'm going to measure, right? So it's like a visual work instruction too, right? Um, and I don't have to say a picture worth 1,000 words, right? So this is the foundation for a visual work instruction. And we can also use the NX synchronized modeling capabilities to add additional material at some stages, right? And again, whenever we do that, the subsequent stages get that updated. Okay, so what I'm doing right now is actually marking the phases in each of the operations, right, with a red color, so that operators can easily identify that. Okay, so we are almost getting done with the stage model surface marking. Okay, so I think I'll skip the fast forward here. Okay, now I'm actually done with my stage models. I've done everything I have to do in NX. I'm saving it back, right? Now, once I save it back, where does that information goes? It goes back to the central the common information repository or the common information platform, which is nothing but the Teamcenter, right? Now, it's available for everybody for downstream consumption, right? So whatever I created is available, right? So even people who don't have CAD access, they can visualize it, right? So whatever we created so far, we call it what is called component BOM, right? Usually there is BOM only for assemblies, right? Bill of materials, we typically talks in terms of assemblies, but in this case for part manufacturing, what we did is actually a stage model or in process development, which is nothing but a series of components, right? So if you really see the operation in a shop floor, we'll start from the raw stock, right? And then we go to each operation, then it goes to the next station, so on and so forth, right? So it's kind of a component BOM, if you will. So which is being shown here, and it's available for visualization from Teamcenter, okay? And which is again connected to the design too, right? So if anything changes in design, we can update this thing easily. So once I'm done with my part in process development, my next step is to do a development process plan, right? So let's see how we do that. So again, as a planner, right, I'm actually tasked to create a process plan for this stage model, right? So of course, I'm going to open this in my part planner application. And what I'm going to do now is actually going to start a brand new manufacturing process, right? So it's like if you are using Teamcenter for design data management, it's just like you create another item, right? In fact, in technical terms, it's just another item type, right? So I'm going to select a ME process type, right? So I have to assign the ID, the revision, right, and the name, just like you create any standard process. So what are the things that's in a manufacturing process, right? It can either contain a set of operations or a set of sub processes, right? So what I'm going to do now is actually add some operations to it, okay? So when I click on new operation button, it shows me what are the operations available, right? Now, if you can see the classification hierarchy here, so again, it helps me to select the right operation pretty easily, right? So I'm going to search for the operation I'm interested, right? It shows me all the operation that's available. So I'm going to do an ACM operation. I can rename it if I want to. Maybe I'll add a inspection operation. Oh, that's thread inserts, right? Then there is a final inspection operation, right? So I'm going to add 3 operations to this, right? I have added 3 operations to it. Then I can also create sub processes to this, right? So what I can do is actually I don't have to start from scratch. So I might have existing templates which I can search and add to this, right? So we'll see that. So I'm going to search for a NC mill sub process. So it's shown me that NC milling process. So I can specify the number of milling operation that's going to happen, right? So I'm telling, hey, I have 4 milling operations, right? So I selected 4 there. So you can see the 4 milling that got added to the process, right? Now, like I said, we created it from the template, right? So each milling sub process has a setup operation, right? A tear down operation, right? And then actually a milling operation, right? So which inside which we have to specify which machine I'm going to use, which we'll see later, okay? So I've kind of added everything I need to do this process. Now I can reorganize it, right? So I can go to the bird view, right? Reorganize. Of course, my final inspection will come only at the last, right? So then I can actually link it, right? And then click on the magic reorganize button or resequence structure. When I do that, you can see on the left hand side, it gets reorganized, right? So that then my final inspection is at the last, right? So it's like initially like a data container, keep adding everything you think is relevant for this, then you can finally organize it, sequence it, right? And sometimes you want to delete it, you can do that too, okay? So right now I have the process structure which shows the operations that need to happen, which is sequence 2. The next step for me is actually to associate the in-process model or the component BOM, right, with the stage model we created in NX, right, which got stored in Teamcenter, to each of these steps, right? So let's see how we do that. So there is an option to link and associate each step, each process element to the BOM element, right? So first I'm going to associate the top level process element to the top level component BOM, right? Then I'm going to associate the sub processes and the operations to the stage model, right? And this is how I do that. Okay. So basically, I'm connecting my process to my MBOM here, okay? Now, the next step, of course, is to specify where this operation is going to happen, right? So that's where I'm going to connect the process to the, let me just go back a bit, to the work area, right? Which is nothing but a bill of plant, right? So you have, what I did here is actually I'm going to search for a small, right? So it's going to show me a small DNC area, right? Which I'm going to use for this process, okay? So it shows me the work area, right? It shows what are the machines available in that work area, right? Then I'm going to connect the top level of the work area to the process, right, or the process plan. Now you can see that once I did that connection and I expand my NC view right here, it shows the DNC work area where this operation is going to happen. And where did that come from? That logic is already automated in my work area template, right? So that as a manufacturing engineer, the moment I connect it, that template has the intelligence to find out, hey, which machine is going to support that operation, right? So there's a lot of automation that we can do when we create a part manufacturing plan, okay? So once I have connected everything, I can go to the Teamcenter report generator and see the part plan we have generated so far in HTML format, right? So this is the view preferred by the shop floor, right? they probably don't care about all the details that's there in that part planner application that manufacturing engineers are dealing with. The output of this can be an HTML report like this, which can be actually given to the shop floor. Okay. Now the plan is sufficiently detailed so that we can move to the next step. And what is the next step? It's actually creating the NC program, right, or the G code. Okay, so moving on to the next step, which is the NC programming. So if I am an NC programmer, right, I'm notified again through my Teamcenter workflow, right, telling, hey, you have to develop an NC program for this process plan, right? So, and everything right, delivered right to their Teamcenter inbox. They don't have to go and search for it. There is no offline copies exchange, right? There is no confusion whether I'm going to develop the NC program on the latest and greatest revision, right, or version of the part, right? Because everyone is actually accessing information from the same central repository, which is Teamcenter, right? So I'm going to click open in the next, right? So once I open it, right, I'm going to go into my manufacturing application, right? So once I go there, it shows me the templates, right? What are the operations involved, so on and so forth, right? So I have to do all my setup activities to generate the NC program, right? So if I move, I don't think I have to show too much of this NC programming capabilities. So what I will do is I'll move forward, right? So once I do the setup, the next one is actually to update individual toolpaths, right? So as a NC programmer, I'm going to do that too. Once I'm done with that, I can move further forward and kind of make sure. So once I update my toolpath and everything, right? We can immediately simulate that in NXCAM, right? So we are going to simulate it and actually see if this is the right one, or kind of do a quick verification. Right, so right now it's actually in the simulation mode. You can do both 2D and 3D material removal verification, right? So this is kind of 2D. Let's quickly move forward here. Of course, I can always rename the output, right, before I save it back to Teamcenter. So we can also generate the operation list, tool list, etc. For this program, right? Again, which will be saved back to Teamcenter, right? Then we are generating the G code, right? Which again will get stored and managed inside Teamcenter, right? And I will show how this part list, tool list, and G code is actually delivered to the shop floor using the shop floor connect. Okay. I'm saving everything back to Teamcenter, and everything is getting saved back to that common information platform, which is Teamcenter. So another thing what we can do is actually, as part of the manufacturing thing, we will have some inspection drawings, right? So we can create that too, right? Again, then associate it with the operation, right? That way, when the operator does that, he or she have access to that inspection drawing too. quickly fast forward here to now. Once the inspection programming is completed in NX, right? Of course, a PDF copy of that will be created so that people who do not have access to NX can also see that inspection drawing, right? And typically, people in shop floor don't have access to NX, right? Saved it. So, like I said before, once I save everything, right? Where does that go? It goes to the Teamcenter, right? Which is the common information platform, right? So once I'm done with my work, I'm going to say, hey, I have done it. Everything I was asked to create, I have created. Everything looks good. I have completed it, right? So this is my standard workflow task. Okay, so now we are ready to manufacture this in the floor, right? So and another quick thing I want to show here is actually, since we manage the creation of this process plan through the workflow, right? The task was sent to a user to create the process plan, and then the G code via workflow, right? The audit history is actually stored in the system, right? So anytime we want to go and look at, hey, who created this G code or who created this process plan, who signed off on it, who reviewed it, right? It's all there in the system in Teamcenter, right? So we can go back and trace back the evolution history of the manufacturing information. Okay. Okay, so the next step is obviously using all the good work we have done so far in the shop floor to produce this part, right? So let's go to that. So this is the machine operator's view. Then when they log into the shop floor connect, right? So it shows. Go back slide. Back. So when they log in, it shows all the machines to which this particular operator have access to, right? Or the work cell this operator have access to, right? So the operator is going to select the work cell in which they are going to work, right? So and then they have to actually download the G code, right? Now they probably would have got notified to do this operation via a workflow, right? So they know how to search for the part and find it. So they're going to go and search for the part. Or the desired operation for that matter, right? So once they get that, right, it shows a quick summary of what needs to happen. And if you see all the tool list and the part list we have created earlier, or the operation list we have created earlier in the NC programming thing, it's accessible to the guy in the shop floor through the shop floor connect application. Where is it coming from? From Teamcenter. Okay, it's no offline copies. Again, the tool setup sheet we created in the NC programming step, it's available for the shop floor operator, right? The inspection drawing we created, it's again available, right, in the same interface. They are not looking for paper drawings anymore, right? And if they want to look at the machine setup, right, the 3D JT view is also available, right, through this applications, right? And of course, I can see the G code, and of course, download to the machine to run that program, right? Once I do all my setup and everything, right? So, and again, I can enforce access controls in Teamcenter to say, hey, only the G code which is released and approved, right, for production will be allowed for download to the DNC, right? I can do that. I can enforce that kind of access controls. That way, the operators don't download, work in progress G code or something which is not reviewed and validated, right? So all those good functionalities available from Teamcenter. I can also, by the way, I can also control where this G code can be downloaded to, right? Even if it's released and approved. Now I connected my part to the work area in my process plan step, right? So when I search for, if I search for this G code in a different work area, it won't be available for the operator to download, okay? Okay, so that's pretty much I had today to show you regarding the part manufacturing capabilities that Siemens PLM and Teamcenter offers. Probably we will open it up for question and answers right now.
Yeah, so we've already actually got a couple questions. So the first one discussing how will reverse input work with the process completion status. That was towards the beginning of.
I'm not sure if I completely understand that question. Probably we will reach out to this user later and then get clarification on this.
There's another question. Can you support PDF documents?
Absolutely, it does, right? Yeah.
Great question. Let's see. The question about resource pooling. We're probably going to need to reach out directly on a couple of these.
How this sorting of process assign, like milling, drilling, type of etc. Again, we for each part, if the question is actually where will we assign each operation, right? That's where we have this stage models, right, which shows each stage of the manufacturing, right? So we will assign it to each stage model, right? If that is the question.
And I think that's pretty much it. The last question actually goes with what I was going to speak with next. Here is a list of our upcoming related webinars. If you'd like to register for these or watch our previously recorded webinars, including this one specifically, you can do that at myigetit.com in the live section there. So all of the webinars that you've seen and this can be seen. And we will have obviously more parts of the manufacturing webinars coming up, or the Teamcenter webinar, sorry.
And if they want to have access to these videos, by the way, this session is already recorded. It will be available in the iGetIt, just like Kyle mentioned.
Yeah, so you'll be able to share that with colleagues and others that you think will find interest.
Right, and again, just to add to that, right, I just gave you a complete overview of the solution highlights, right? And sometimes, some of those things you may not be planning to adopt on day one, and you probably want some more details on some of the specific areas, right? If you could please reach to us, we can have detailed dive down sessions on each of these capabilities.
Definitely, yeah, please. All right, well with that, I believe that's all of our questions, and we're very thankful for you guys showing up today. Again, I'm Kyle Heithaler, the iProduct Sales Manager, and this is Pradeep Peter, our Business Development Manager. And from Tata Technologies, we'd just like to say thank you. Have a great day.